za prezentację. A teraz przed nami Luca Gibelli, CEO i współzałożyciel startupu Skylable, wcześniej zaangażowany w projekt o globalnym zasięgu pod nazwą Clam Antivirus, ekspert w dziedzinie przechowywania, składowania danych w chmurze.
Hi everyone. Whoa. Hi everyone. So I will do this talk in English. If you don't understand me, just stop me. Feel free to ask questions. This is not a formal talk, it's just a conversation with you guys, so no worries. So a little bit about us. What is Skylable? We are a startup which was incorporated in 2013 in London. We do most of our research and development in Toronto. We have 2 offices there inside the Exia complex. And what we do cloud storage. So if you need to store massive amounts of data in a safe and reliable way, Skylable is the solution. This is my team. It's not our first time around. We are also the authors of ClamAV antivirus. If you use Linux, you might have heard about ClamAV. It's the most famous open source antivirus for Unix. We started developing ClamAV in 2002. In 2007, we were acquired by SourceFire, a company quoted on the Nasdaq market, which was later acquired by Cisco. So now ClamAV is a Cisco product. It was very successful. So if you're using Google Drive, your data is scanned by ClamAV. Google uses ClamAV for most of their services, including Gmail. If you're using Facebook, your data is scanned with ClamAV because all pictures uploaded to Facebook are scanned by ClamAV. And well, if you have an email account, for example, on wp.pl, it's also protected by ClamAV. Allegro uses ClamAV, so it was really a successful product. So where are we going? Well, Skylable, like I said, it was incorporated, it was registered in London, but most of our developers are here in Poland, in Toronto. We are hiring, by the way, so if you're looking for a job or for a better job than what you have now, do send me your CV. We got a seed investment from Sunstone Capital. It's one of the leading VC firms in Europe. They're very active in open source development, open source projects. They're based in Denmark, but they invest everywhere in Europe. So now that you know a bit about Skylable, let me tell you in detail what we do. You know about big data. You hear this term, big data, almost every day, right? Do you know what is big data? Raise your hand. Okay, so what is your definition of big data?
For me, I am mostly interested in HTTP requests. Okay. So 2 megabytes of request for me is a big data.
All right, but why do we talk about big data? Why it's such important in nowadays, big data? Why companies invest so much? Why company invests so much in big data?
Do you mean by storing data?
Yeah. Why big data is useful?
For me, it's useful because you can, I don't know, give some information.
Exactly. So, big data, if you want to give a simple, I don't know why it keeps making this noise, maybe I should be a bit like rap style, I don't know. Anyway, if you have to give the simplest possible definition of big data, I would say that it's like a GPS for companies. So you can think of it as your guide for making critical decisions for your business. So if a company has to make some decision that can affect the future of the company itself, it cannot rely simply on the so-called IPO, the IC profile and IC paid opinion of some employee. It has to rely on the actual data. So instead of simply saying, instead of simply hiring some expert to tell you what your business should do, because that expert could be right or wrong, you don't know that. You should rely on the actual data, on some facts, and in order to have to make an informed decision, you need to store and analyze large amounts of data. So this is what big data is. It's just the way that you make decisions, critical decisions, in this decade, let's say, since 2010. Instead of just relying on your gut feeling, on what your intuitions are, you rely on the actual data. Now, the problem is that this means that you have to collect a lot of data, and you have to collect it from every possible source. And it's not easy, so you have to dig really deep into what you have. You have to analyze every single bit of information that you have available. That means that, for example, you could analyze how your customers are moving their mouse when they visit your website. So you should even collect how your mouse is, how the visitor's mouse is moved over the web page of your website during some fraction of a second. So you have to analyze every single bit of information that you can collect, and you have to collect as much data as possible. But collecting data is not simple, because first of all, it poses two challenges. The first challenge is to actually identify what is interesting for you, and the second challenge is to actually store this data in the long term and in a reliable way, so that this data stays available in the long term, right? So how big is big data? Well, it's very big. You cannot simply say, I think 10 terabytes will be enough for 1 year, or 20 terabytes will be enough for 1 year. You just have to prepare to scale indefinitely. So if today maybe a 2-bus floor seems enough for you, maybe tomorrow even a 3-floor bus will not be enough. So you can scale a storage up to some limit, right? You cannot simply rely on a single device, on a single bus in this case, because you never know when you are going to run out of space. So you need multiple buses rather than a bus that can grow vertically. So Skylable focuses on solving the problem of storing large amount of data. We cannot tell you how to analyze this data and how to collect it. We can just tell you how to store it. So the way we do it is the way the cloud, like a private cloud. Okay, so instead of storing the data in single storage devices like it has been done so far, like you could buy a storage on a network from Meetup or from EMC and put that much data in them, we use a cloud approach to storing data. So now the question is, what is the cloud? Well, can you define the cloud? Have you seen the movie Sex Tape, for example? Anybody of you? Any of you has seen the movie Sex Tape? Okay, so what is the definition of the cloud in Sex Tape? Well, it's a simple. There is no definition. They say nobody knows what is the cloud. It's a fucking mystery. So yeah, I actually have a simple definition of what is the cloud. The cloud is in the public cloud, which is the topic of the movie, of course. And the definition is somebody else's computer. So when you put your data in the cloud, in a public cloud, you are just putting your data in somebody else's computer, which can be very big or extremely big, but it's still somebody else's computer. So when you put your data in a public cloud, you are actually giving your data to somebody else, to a third-party entity. And this can be risky because you are basing your strategy, the business strategy of your company on data which is also valuable to another entity which could become your competitor one day. So this is wrong. I mean, it's like giving your business strategy to somebody else, and then it becomes very easy to compete with your business. So what is the solution? Of course, it's to avoid giving your data to somebody else and instead keep it local, right? So store it locally. But how can you store large amounts of data without putting the hassle of setting up a large storage cluster onto somebody else? So how can you store large amount of data locally? Well, what happens usually is that companies end up having what I like to call the storage salad. So they just buy many bricks, in this picture they are represented by Lego bricks, but you can think of it as storage bricks, so storage systems. They quickly run out of space on each storage brick, and then they have to buy a new brick, a new storage device. But then maybe they don't buy the same model as before. They buy a larger model which uses a different interface, a different setup, and they end up with the storage salad. They end up with many different storage devices which have different ways to be accessed, different systems and different prices also. So they end up with an environment which looks really messy and which is really, really difficult to maintain in the long term. Because think about this, say that you have to store 100 terabytes of data on different systems. You lose track of where are you putting the data. You no longer know if you are putting it in the old system, if it has been migrated to the new system. You start losing track of where you are storing your data. So the solution to this problem is software-defined storage. Software-defined storage is a new paradigm which is becoming more and more important in the last few years. And the idea behind the software-defined storage is that you don't need to buy different systems, different appliances, different storage. You just keep buying servers, okay? Any kind of servers. Even if they are different inside, you don't care about that because you install the same software on each server. So you have many different servers, many with different characteristics, with different, even from different vendors, but you install the same software on each of them. And so they act like a single thing, like a single entity. And you access them always through the same interface. So there is a single interface to access the storage made available by all these servers. And so it looks more tidy up, more ordered. It's something that can be maintained in the long term, because you have the same storage available in the long term. It's always the same interface, always the same software. You don't care about the underlying layer, so the actual hardware. You just see that the software is always the same. So, what are the challenges of software-defined storage and in general of storing big data? The challenges of storing big data is of course size, speed, and location. So if you start, actually let's go through each of them one by one. So about size, when you store big data, you want to be able to scale horizontally. So if you buy a single device and then try to add more storage to it, add more shelves, more hard drives, you can scale up to some limit. At some point you always hit the physical limit of that storage system. With software-defined storage, instead, you can scale horizontally. So you will never hit the physical limit of a single machine. You can actually keep buying more servers, add them to the cluster, and you get always more and more space. So this is future-proof. You don't have to worry about actually sizing the system when you buy it. You just buy what you need now, and then you grow it gradually as your needs increase. So what speed? Again, with the traditional storage area networks, you are limited by the speed of the controllers, of the network interfaces, of the storage area network. With software-defined storage, instead, you are not limited by that, because you can aggregate the speed of multiple servers as a single entity. And then, again, there is the comparison between public clouds and private clouds. So, in public clouds, you're giving control of your data to some third-party entity. In private clouds, you are keeping control of your data because the data stays in-house. So, it's near where you want it, because you want to analyze your data in-house. And it also guarantees your privacy, because you are the only one who has access to your data. So, now that we have analyzed the advantages of software-defined storage over the traditional storage area network and public clouds, the question is, which software-defined storage is right for you? So there are many software-defined storage technologies available on the market. Some of them are commercial, some of them are, expensive. Some of them are available also as open source software, and they are free to download. So in this presentation, we just focus on the ones that are open source and who have a free version available online. So they are React, CS, GlusterFS, Ceph, Hadoop, and of course Skylable. So what is the difference between Skylable and the other software-defined storages? Well, first of all, most of them, especially Ceph and GlusterFS, are really complex to install and run. So you have to really have some expert system administrator available in your company to deploy them effectively, or you have to pay the producer of the software to deploy it. The second thing is that they only support, and here I'm referring to React CS and Ceph, they only support the S3 protocol. The S3 protocol is the one, it was invented by Amazon, and it's the one that it's becoming an industry standard for object storage. However, it was built for public clouds, so it's optimized for public clouds rather than private clouds. And it doesn't work really well with private clouds because it always assumes that there is a single point entry for clients to connect to the servers. And the third thing that all of these are missing is the duplication. So one important feature of Skylable, which differentiated from the other solution, is that we support the duplication. So if you never store the same data twice in Skylable. If you already uploaded part of your data to the cluster and you start uploading it again, it just gets deduped. So you avoid duplicating traffic, uploading the same data twice, and you also avoid storing the same data twice. And this translates in saving a lot of time during network transfers, and also saving storage in terms of disk space. So what else can do Skylable better than their competitors? We support geo-replication, so you can actually have multiple Skylable nodes distributed geographically over multiple countries worldwide. And this is something that our competitors cannot do. They always require all the nodes of the cluster to be installed in the same data center. Well, this is something that we actually do just like our competitors. We support the S3 protocol. So if you are migrating your service from S3 to Skylable, you can do that transparently because we support S3 protocol. We support data replication, so you can have your data is safe because it's replicated between different nodes, and if a node fails, you still have access to your data. We support self-healing, so if one node fails in the cluster, one or multiple nodes fail in the cluster, you can just replace the node with a healthy node, and the cluster will automatically heal itself. The installation, the deployment of Skylable is particularly easy. We have tools that allows you to deploy a cluster with any number of nodes in literally minutes and with a single command. So if you need a Skylable cluster, you don't have to hire an expert system administrator. You can just run a single command and the cluster is up and running. We do one thing well. Again, this is something that, in our opinion, our competitors got wrong, because they tried to develop a solution which solves multiple problems. So, for example, Ceph tries to be both a distributed object storage, but also a distributed block storage, and also a distributed file system. This is not really the way to go. I mean, in the Unix world, the way to go is to have a tool which does just one thing well. If you try to do many things, you end up doing none of them well, and then you are useless. So Skylable does one thing well: distributed object storage. So if you like what you saw so far, go to our website. Skylable is open source and released under the GPL license, so it's free to download and run. You can try it. There are packages, binary packages available for almost every distribution. We also have a nice thing, but I will get back on this later. We offer commercial support and some premium features which are mainly interesting for large enterprises, like Active Directory support for authentication, LDAP support, Open authentication support, and some other things. But most of the stuff is free for everyone. So we also, among the commercial features, we also offer accounting and billing and the ability to index your data and search inside your data. So you can, for example, store presentations, documents, PDFs, and search for the file by some keyword which is inside the document. We are hiring, so we have a couple of offices in Torun. We are looking for Python developers, C developers, and also for some graphic web designer. We're actually looking also for Java developers. We offer European standard salaries, so send me your CV if you are interested. And that's it. So I just wanted to finish this talk with some... Do we have the time? Yeah, so I wanted to ask you a few questions about how much you care about your privacy. I'm really curious to know from a possibly tech-savvy, well no, a surely tech-savvy audience, what is their take on privacy and public clouds. But first I saw that there is a question, yeah?
It's an answer. I care about privacy very much, so I don't really use a cloud at all. For my private pictures or data, I don't use a cloud at all.
Okay, I couldn't hear you very well, so...
I said,
Maybe if the cable is long enough, it's not, but you can come here. There we go.
Okay, thank you. I said that I care about my privacy very much, so I don't use cloud for my private things at all.
All right. So, how many people agree with him? What's your name?
Mariusz.
So, Ariusz? Dariusz?
Me.
Mariusz. Okay. How many people agree with Mariusz? Okay, not too many. So, not many people care about their privacy. That's too bad. So, before I ask you this question again, let me ask you another question. How many people actually are using Dropbox here? Okay, many people. How many of you has read the terms of and conditions of Dropbox? 2, okay. So did you like them?
But I also read the terms of usage Google Drive.
Alright.
Google Drive.
Whatever.
I was shocked that my files are owned by now.
Exactly. So if you read
I'm not the only owner of my files anymore when I upload it to Google Drive.
Exactly. So if you read the terms and conditions of Dropbox Google Drive, you will see that when you put something there, you are actually giving a license to them. A license to redistribute your files, a license to analyze your files, and a license to give your files to third parties. And there is no definition of what these third parties are. They could be really anyone, okay? So this is what public clouds do with your stuff. Now, let me ask you again. How many people care about their privacy of the files that they put in public clouds? Yeah, so it's a bit better. Now, the question is, there has been a shift in the perception of the security of public clouds in the last few years. I mean, the cloud has become so pervasive with our lives that we cannot live without it, right? But we have given up too much for the comfort of having all of our data always with us. I mean, just stop for a second before the next time that you put some of your data in the cloud and think about what it really means, what you are doing. Because companies are using this data for their benefit. So I can tell you a couple of stories about this, real life stories. So why I started this presentation with big data? Because this is exactly what public clouds are about. You put your data, you are the product. You are putting your data in a public cloud because you want a service for free, which is very often for free or almost for free. You put your data in the cloud, you receive a service. What does the company get in exchange? For sure, not profits, because most companies are selling you cloud space, cloud storage, maybe not entirely for free, but almost for free, for sure for a loss. So when you buy Dropbox storage for, I think it's like $30 per year, 30 euro per year, something like that, and you get 1 terabyte, Dropbox is losing money on that, okay? I mean, if they would just provide this service for 1 terabyte for 30 euro per year, they would be losing money on it. Now, so where do they make money? They make money by analyzing all the data that they get from their users. And this is scary. So it has become easy for companies to predict what you will need. There was an interesting article from, I think 6 months ago, about how Tesco, the supermarket chain, could discover that a woman was pregnant even before her husband knew it. Okay, because they could just analyze her behavior by what she bought with her loyalty card, about what her diet, how her diet was changing, which products she was looking for, and which product she stopped buying. And by analyzing this data, she could predict with a certain accuracy that she was pregnant. And this is even before her husband knew it, before she told her husband. So this is what we are talking about. We are talking about giving companies the ability to predict what we want, what will happen to our lives, what we are doing, and what we will need. Okay. And when you use public clouds, you are just giving them that information. You are not just using their service. You are giving some information to them. This is not good, because they can actually use it to shape your life somehow. They can use it to force you into doing some things that you normally wouldn't want to do. So I think that we have to start to be a little more careful with what information we give to big corporations, and start thinking about finding other ways to have the same comfort that the cloud gives us, but with better privacy. So I agree that the cloud has brought us many benefits in terms of easy of life. I mean, there are many benefits in using the cloud and in big data. For example, when you use Google Now, it's a service that can predict where you are going. When I wrote in my calendar that I had an appointment here, that I had a speech here in Bydgoszcz, so I got a notification from Google Now that I should leave 20 minutes sooner because there was some traffic between Torun and Bydgoszcz. So this is good use of big data. But when companies, big corpo, use this information to, I don't know, to sell me some specific service, or to force me to use some specific service, then it's not good use of big data. So Skylable is just this. It's a way to take back your privacy, to get the same benefits of public clouds, but without giving access to your data to third parties. And we also offer a Dropbox-like application. So it's called SX Drive. It's already available for Android. It will be available for iOS soon. And it will be also available for Windows, OS X and Linux. And it works exactly like Dropbox. So you don't need to give up the comfort and ease of use of Dropbox, Google Drive or Box.net or OneDrive, whatever you are using. You get exactly the same features, except that your data is stored in a private cloud, in your own private cloud. Or it can be encrypted client-side. So this way you can really, I mean, this is our way to give back to people the ability to store their data in a safe way, comfortable way, and at the same time of keeping their privacy. Question?
Once more, what is the name of the service?
It's not sold as a service, so you still need to deploy your...
But what is the name? Let's say I would like to buy something.
it's called, we call it SX Drive. SX Drive.
It's your service, right?
Yeah, exactly.
What is the cost of using
So
the service?
it depends on what, on how much data you want to store.
Okay,
So
let's say I have unlimited bandwidth and unlimited storage on Skylable because I have the Office 365, but I have only 20 gigabytes of data.
alright, so it could be as cheap as maybe $10 per month, something like that. I mean, it all depends on where you want to run it. So let's say that you have already a computer at home, okay? Let's say that you have an internet connection which is fast enough for your needs and which is and you have enough space on your hard drive, which is free.
What should I do if I would like to care more about my privacy and I also would like to have this comfort of having availability to using to get my data from any device?
Alright, so this is now I get your question. So this is the idea. You should have you should just buy a cheap and let's say not very fast computer. Put it in, leave it on in your room, connected to the internet, of course. So you need a 24/7 internet connection.
I would like to pay, for example, you to handle this PC or server, not to handle it on my own.
Alright, yeah, we can do that. But the idea is that, I mean, we don't plan to sell it as a service, but indeed we get this question more and more often, so we might start considering it. So our standard, let's put it this way. Building a Dropbox-like service with a Skylable cost is about €11 per year for 50 gigabytes. That's the standard price.
But the Dropbox don't care about my privacy. And if I care about my privacy, what can I do to still have the comfort of handling my data in the cloud and also to some better privacy than I have already at Skype?
So the idea is that you must use a client-side encryption. So you must encrypt the data, but with the key kept on the client side. So one of the things that Dropbox announced, you know, with a lot of PR and a lot of reclama, was that they supported client-side encryption. Now, client-side encryption is pretty useless because you put your data in Dropbox and you give Dropbox the key to encrypt the data. But That means that they can also decrypt the data, so encryption doesn't add anything. With Skylable instead, we have native support to encrypt the data client side. So you never give us your encryption key. The key stays on your computer, on your side. We don't know that. So we just see garbage stored on our servers, but you have access to your data because you can decrypt it with your key. And this is how it should work, right? How encryption should work. Server-side encryption, like what Amazon offers, what Dropbox offers, is pretty much useless. So to answer your question, we offer 50 gigabytes for about 11 euro per month. 11 euro per year. That's about €1 per month. It's quite cheap. And you get client-side encryption. If you don't want to install your own hardware, on your own server, in which case Skylable is totally free. You get the same service, but totally for free.
Let's say I have a startup. Some startup which is collecting very much data, but we have added data, and we have to store it in some way. So what is the cost of starting collaboration with such a company, such a startup like yours?
So we offer commercial support and also some premium features, which I mentioned before, to startups, and the price is around $10,000 per year. $10,000 for the first year, $5,000 for renewals.
Yeah, but are there any limits like bandwidth or storage space?
No. This is just limited to 20 nodes. So anything that you can store on 20 nodes, which is pretty large because
one node is how many?
There is no limit actually. So you could have 20 terabytes per node, 40 terabytes per node.
And what is this node exactly?
Sorry?
What is this node exactly?
So the node is a server, just a single server. So you can have up to 20 servers.
There is 20 different ways of using data, right? So
What do you mean 20 different ways?
when you tell node that I can use each node in a different way.
No. So the cluster is seen as a single entity. So you just access the cluster as a single entity, and you don't care about where your data is actually in the cluster. You use them all in parallel. And yeah, so the $10,000 per year license is just for cluster up to 20 nodes, which tend to be pretty large because it's normal to have 24 terabytes per node. It's the typical recommended size. So we are talking about half petabyte. So for half petabyte storage, you just pay 10,000 per year. It's not that much.
I also have been on TEDx Bydgoszcz. There was some talk about data stream, and there was said that the data stream is so big that we cannot, let's say, check the data which was, for example, 1 hour before, that we only can see the data which are now. Only now we can analyze the data, we cannot revert it in any way. So how do you recommend to analyze such the data if we have so many that we cannot analyze everything?
Okay, so the question is, when you get a lot of data, how can you analyze it in a responsive way, right? Well, it all depends. This is a totally different problem because we just care about how to store this data and how to provide it to the computing nodes in a fast way. So it's a problem which can be solved with computing clusters like Hadoop, for example. So it's all about map and reduce. That's how most big data companies do that. They just implement Hadoop clusters which are big enough to analyze large streams of data in a timely way. Okay. Any other questions? I think we are running quite late. Okay, so thank you all.
Thank you, Luca. If you have more questions, please ask Luca. Grab a beer with him and ask him. So, a few minutes. Okay, właściwie już możemy przejść na polski.